In this lesson, we're going to talk about the domain and the range of various functions. So here we're going to first talk about what it is to be a function and what is a one-to-one function, and then we're going to look at different graphs and identify the domain and range in two different notations. First, we want to be familiar with some vocabulary. So the first thing we want to make sure that we know is what domain is, and domain is the set of x values to be evaluated, and this is also known as the input values or independent variable. Range is the set of y values to be evaluated, and that's also known as the output values or dependent variable. So here we can see there's four different representations of domain and range. So right here we have a table of values. All of the x values are the domain, all of the y values are the range. Here we have a set of ordered pairs. Again, the x's are the domain, so the first term, and the y values, the second term, are the ranges. When we're looking at graphs, the domain again will be the x values, so we're looking from left to right on the graph, and the range is the y values, so we're looking from the bottom to the top. Okay, and we'll get into how we actually write these in a little bit, but just identifying kind of what they look like. Another important vocabulary term is a function. So every time that we have x's and y's, so points or a table of values, that is called a relation. And sometimes relations are functions. So a function is a relation in which each element of the domain corresponds with one element of the range. Okay, so what that means is when we look at this ordered pair here, these ordered pairs, we want to see if each element of the domain, so each x value, if it corresponds with one y value. So when we look at this, we can see that the domain is 3, 6, 3, 2. Since these threes are repeating, okay, this is not a function because in order to be a function, the x value of 3 has to have exactly one y value. But here, x is 3, y is -6. Here, x is 3, y is 0. So since there's two different y values that go along with the same x value, this is not a function. So not function. It's just a relation, it's not a function. If we look at this table of values here, let's look at the x's. None of the x's repeat. So since the x's don't repeat, this is a function. Okay, so we're really just focusing on the x's. Here the x's repeated, not a function. Here they did not, so it is a function. Then we can look at a graph and tell if it's a function or not by using the vertical line test. So it checks to see if a graph is a function. If we were to draw vertical lines through the graph, if it crosses the graph more than once, it is not a function. So I'm going to draw a vertical line. Okay, we can see that it crosses this graph at 2 spots. Since it's crossing at 2 spots, this is not a function. That means that the same x value has two different y values. Okay, if we look at this graph, we can see, if I draw a line, and you can draw a line anywhere. So I'll draw a line here, draw a line here. We can see every time we're drawing a vertical line, it's only crossing at one point. So that means that this graph is a function. Okay, the horizontal line test will check to see if the inverse graph is a function. If any horizontal line passes through the graph more than once, then the inverse is not a function. So it's the same idea as the vertical line test, but now we're going to draw horizontal lines. So if we look at this first graph, if I draw a horizontal line through, I can see it's crossing at 1, 2, 3 spots. So that means that this is not a function. This would be the graph of an inverse, and we'll talk about inverses later on, but just knowing that it's failing the horizontal line test because it's crossing more than once. If I were to draw it here, right, that only crosses once, but that's why we need to draw multiple lines so that we can see over the entire course of the graph, is this crossing once or more than once? So even though it only crosses once here, it's crossing more than once up the top. So, sorry, I meant to write not a function. Okay, so this is not a function. Okay, if we look at the next one, draw a horizontal line, and I'll just kind of draw a couple. Every time I'm drawing it, it's only crossing once. So that means that this inverse is a function. Okay, and then a one-to-one function is a special function. So this means that each element of the domain corresponds with one element of the range, which means it's a function, and vice versa. So one element of the range corresponds with one element of the domain. So when we're looking at a graph, it must pass both the vertical and horizontal line tests. So when I'm looking at a table of values or a set of points, we are checking to see if the x's do not repeat and the y's do not repeat, then it's a one-to-one function. So I can check here, right, looking at the x's, none of the x's are repeating. -2, -1, 0, 1. Perfect. If we're looking at the y's, 3, 2, 1, 0, they don't repeat. So since the x's don't repeat and the y's don't repeat, this would be a one-to-one function. In this graph here, it has to pass the vertical and horizontal line test. So if I draw vertical lines, all the way through, right, it passes the vertical line test. If I were to draw horizontal lines, it fails the horizontal line test because it's crossing more than once. So this passes the vertical, fails the horizontal, so this is not one-to-one. Okay, and then in this last one, same kind of idea. We'll draw vertical lines, okay, passes the vertical line test. If we draw horizontal lines, okay, it passes the horizontal line test as well. So this is one-to-one.